title of the presentation is the Pretreatment technology for enhanced bio-ethanol production from municipal solid waste. This work has been carried out at the CyTEMA, and this researchers are from the Chemical Engineering Department of the University of Toledo. We see a brief intake of the presentation. We will start the introduction, then we will see the objectives, methods, results, finally we will see the questions. As a brief introduction, we would like to highlight that the municipal solid waste production is significant high, about 220 millions of tons per year. Some of these wastes are organic substrates, and nowadays most of these organic substrates are going to landfills, and we are not taking advantage of the chemicals or the energy contained in this kind of waste. It's important also to remark that the production per inhabitant in Spain of municipal solid waste is decreasing with time. And anyway, we are producing a significant amount of waste every year, about 500 kilograms per inhabitant and per year. The raw materials contained in this waste can be used to extract chemicals or energy. To extract the energy, we can perform a hydrolysis, acid alkaline, or even a bio-hydrolysis by means of enzymes. In this way, we can transform the substrate that then could be fermented to produce several chemicals. The most important in this case was to ferment the glucose, the saccharose, the glucose molecules into ethanol. This ethanol can be separated from the rest of the waste to obtain a bio-ethanol from waste. In this way, we are extracting some of the energy contained in the waste. Nowadays, this kind of waste are difficult to be transformed into ethanol, and in order to enhance the yield, to enhance the production, several pretreatments should be performed. Mechanical, for example, milling or with ultrasound waves, thermical, with water steam, or liquid water at high temperature, physicochemical with ammonia or CO2, also chemical, with different chemicals, acid, mainly sulfuric acid, also wet oxidation, some alkaline hydrolysis, or also with organic solvents. And also the pretreatments are related to bioprocesses, such as the use of smoke or organic solvents that are extracted from biomass. The main objective was to study the possibility of the bio-ethanol production by means of the aerobic fermentation of the municipal solid waste. So this main objective has several minor objectives. First, we transform the municipal solid waste into a liquid effluent, because the microorganisms only can transform the chemicals dissolved in the water. Then this liquid mixture of the municipal solid waste was fermented, and we studied the effect of the pH value, how it was influencing the fermentation to produce bioethanol. And also we studied the effect of the pretreatments by evaluating the yields and the rate for the bio-ethanol production. In the first stage, we use a small reactor to extract the chemicals contained in the municipal solid waste into water. To do that, we add 500 grams of municipal solid waste, and we mix with 1.5 liters of the mineralized water. We mix the system at 150 RPM, and we fed nitrogen to wash out the gas production, mainly hydrogen and CO2. Here we see a picture of the reactor. Once the organic compounds were extracted and they were dissolved into the liquid, into the water, the second stage was to study the fermentation of this liquid. To do that, we use a reactor. We also feed nitrogen gas to remove the gas produced during the fermentation. And we add to this system the synthetic municipal solid waste liquid extraction. The COD concentration was 1,000 milligrams of COD per liter. Here in the reactor, the reaction takes place, and the organic compounds, mainly glucose and fructose compounds, were fermented to bio-ethanol. The reaction was carried out at 26 degrees because it was observed that this was the optimum condition. And also, we performed experiments controlling with pH control and without pH control. In all the cases, the initial pH of the experiments were 5. You can see a picture of the reactor. The stages of the experimental procedure were divided into several stages. The first, the study of the pH effect, with experiments with pH control system and with pH control, and then we evaluate the effect of several pretreatments. We select the addition of sulfuric acid. In this case, what we did was to add 0.75% of sulfuric acid to the liquid with the organic compounds of the municipal solid waste. And also we did in 1 hour at 121 degrees. Then the addition of calcium hydroxide. To do that, we add 0.5 grams of calcium hydroxide per gram of municipal solid waste. And finally, also we perform a pretreatment, adding previously a small amount of ethanol to enhance the reaction. In this case, we add the ethanol and sulfuric acid. We heat 160 degrees during 70 minutes. And finally, after all the pretreatment, we separate the chemicals to be removed from the liquid system. The first stage, the main results were the following. So we tried to extract the organic compound, the municipal solid waste, into the water. To do that, we indicate 500 grams of municipal solid waste, and we add 1.5 liters of water during 14 days, and we obtain a liquid effluent with a COD concentration of about 16,000 milligrams of COD per liter, a concentration of solids, of total suspended solids and volatile suspended solids about 7.3 times 10⁻³ grams per liter, and the TOC was about 1,300 milligrams per liter. So we were able to extract most of the organic compounds of the municipal solid waste into this liquid. Then we studied the anaerobic fermentation. As we indicate, we performed the test with and without pH control. And the main results were about the total and volatile suspended solids. We obtained similar removal, even better, without pH control. Regarding to the ethanol production when no pH control was carried out were significantly higher. And about the CO2 and hydrogen generation, it was also higher when no pH control was carried out. So what we observed was that it was better, the system, the biofermentation was better when the pH was not controlled. Then we studied the pretreatment to enhance the ethanol production. First, we add sulfuric acid, and what we observed was a significant decrease in the total and volatile suspended solids removal, and then a linear reduction. So the first decreased, the step decreased was related to the hydrolysis carried out by the sulfuric acid, then to the hydrolysis of the microorganisms that we use. We use in all the experiments Saccharomyces cerevisiae. About the ethanol production, also we saw a significant increase in the ethanol production, and then after 20 hours a linear increase, but find the results obtained previously, so these are related to the action of the sulfuric acid and this to the bio-fermentation. And about the CO2 and hydrogen generation, the results were more or less the same, significant increase at the beginning, then a linear relation, indicating that the effect of the pretreatment with the sulfuric acid was mainly observed at the beginning, and then the linear trend observed was related to the fermentation of the rest of organic compounds in the liquid water. Then we perform a pretreatment with calcium hydroxide. The total volatile suspended solid, we observe more or less constant removal of volatile and total suspended solids at the beginning, and then a linear step. So this could be related to inhibition of the microorganisms that were removing the solids, and after several hours, about 55 hours, the microorganisms finish the lag phase and start to consume the small solids that were contained in the system. While the ethanol production, similar result was observed. At the beginning, no ethanol was obtained because the microorganisms were in the lag phase, so they were not able to ferment the substrate contained in the water, and then the ethanol production increased. And about the CO2 and hydrogen generation, the trend was more or less the same, and almost no production at the beginning, and then a significant increase. This is also related to the ethanol, to the fermentation of the solids contained in the waste to ethanol. Finally, we did a study adding a small amount of ethanol to the system. We observed that the addition of ethanol reduced significantly the amount of suspended and of total and volatile suspended solids in the system. The ethanol production was also significantly higher, so we enhanced the ability of the microorganisms to ferment the organic substrate to ethanol when we add at the beginning a small amount of it. Now about the CO2 and hydrogen generation, the trend was more or less the same to that of the ethanol production, because these gases are released because of the reaction, of the fermentation reaction to ethanol. So comparing all the results, you see that in terms of total and volatile suspended solids, the pretreatment removing the higher amount of it was that with ethanol. About the ethanol production, the higher production was observed when we add sulfuric acid. And about the CO2 and hydrogen generation, the higher production were also when we add sulfuric acid, because as I indicated previously, the gas production, CO2 and hydrogen, are significantly related to the ethanol production. So as main conclusions, we can say that the sulfuric acid presents the best result. We have obtained about 50 milligrams per liter per hour of bioethanol. It's about 4%, 0.04 milligrams of ethanol per gram of municipal solid waste per hour. The pretreatment with sulfuric acid during 70 minutes yields about 0.192 milliliters of hydrogen per milligram of ethanol produced, and the best pretreatment to the reduction of the suspended solid were obtained with ethanol. So as a main conclusion, we can see that the best pretreatment is the sulfuric acid addition, because it enhanced the ethanol production. This was the main objective, but also we need to pay attention to the ethanol pretreatment, because it allows to reduce significantly the amount of suspended of total and volatile suspended solids in the system. So thank you very much.